Welcome to Implementing Algorithms in FPGAs. My name is Spanta, and we are going to go through dramatically accelerating implementing FPGA algorithms. And the way this is going to be achieved is by studying and understanding the algorithm development and FPGA implementation, and especially the intersection between the two. Algorithms are a set of calculations that are performed on an input, such as from a sensor, a data feed, or a file. And algorithms can be computationally intensive, and this is why an FPGA's horsepower is so desired. And to understand the FPGA is an important step. An FPGA is similar to an assembly line in a factory where a car is being assembled, and from station to station, additions are being done. At this station, a hood is being installed, and at this station, wheels are installed, and at the end, the output is the final product. Much in the same way, a mathematical algorithm is performed in assembly line in the FPGA. In this example, a stock price is being provided in real time during market hours. And if at this station we subtract the purchase price, we would have the gain per share. And if at the next station we get the product by multiplying with the number of shares held in the account, the total gain that has been accrued in the portfolio is the final result. Now, if we take a chance to say, hey, if we plan our algorithms for the assembly line, we can achieve gains the same way the auto industry has understood the assembly line and achieved gains in that industry. And we should take an example. A simple example that is applied in all fields is the calculation of a mean and variance. Now, if we look at these equations, one thing that we would note is that the variance calculation involves taking the mean and using that as a calculation on every single sample that is being used in that data set. So what that would mean, if this set of equations is handed from the algorithm developer to the FPGA implementation team, is that they would calculate the mean, then store the samples in memory, read the data back from memory, and calculate the variance. And this could end up being a complicated process depending on the size of the data set and the available memory. However, if one were to take this set of equations and examine them and redistribute the math, a much more simple equation is arrived upon. And in this equation, we would note that the mean is not applied to every single sample individually. The individual samples have their set of calculations provided on them, and at the end, the square of the mean is subtracted from it. So in that block diagram, we would notice that there are parallel paths of calculations being performed and still using the assembly line process that the FPGA is so good at. And the mean and variance are the final products that are achieved. And by going through this 15-minute exercise at the development of the equations that would be implemented, the implementation time has saved roughly about a month. By my estimation, this takes about a month to implement in an FPGA, whereas this approach should take on the order of 1 day. And this is where Valley Digital thrives at. We do algorithm development, FPGA implementation, and concentrate very heavily at their intersection to achieve the schedule and budget savings that our customers love. And if you have comments on this video or want to get in touch, I can be reached at valleyd.com.